Hi, I'm Mr. Oh Ming Yeo. Okay, I'm going to go through how do you find the refractive index N with angle of incidence I and angle of refraction R. Okay, now let's take a look at the case where the light travels from air to glass. Okay, when the light travels from air to glass, which is from an optically less dense to a denser medium, the light ray is going to bend towards the normal. So in this case, it forms 4 angles. Okay, so only 2 angles are useful to us, and that is the angle of incidence, which is between the incident ray and the normal. So this angle, we call it angle I. And the angle between the refracted ray and the normal, we call this angle R. Okay, and there's another 2 angles here indicated by the red marker. These 2 angles, they are useless angle. Okay, and sometimes the questions will give you these two useless angle to confuse you. Okay, so what do you do when they give you this kind of angle? You have to take 90 degrees minus off the angle to find angle I or angle R. Okay, so now we can write down the formula for refractive index. Okay, in this case, the refractive index is equal to sine I over sine R. Okay, now let's move on to the case where light travels from glass to air, which is from a denser to less dense medium. The light ray will bend away from the normal, and in this case it forms 2 angles as well, angle I here and angle R. Okay, the refractive index formula when the light ray is moving from a optically denser to a less dense medium is different from the refractive index formula when it's moving from less dense to denser. What is the difference? The difference is that we just need to invert the formula. Instead of sine I over sine R, right, now it becomes sine R over sine I. Okay, and some students will get confused by this because it's the same kind of questions, but yet the formulas are actually inverted. Okay, so one way of preventing this kind of confusion, right, is that we can combine these 2 formulas together. Okay, as you can see, sine I is on top of the fraction and I is the bigger angle of the 2, and sine R is on top of the fraction here because angle R is the bigger of the 2 also. So in this case, we can combine these 2 formulas and we write down the refractive index is actually equal to sine of the big angle over sine of the small angle. Okay, so let's try to make sense out of this. Look at the light ray moving from air to glass. Angle I is bigger, so we say that refractive index is equal to sine I over sine R. And from glass to air, angle R is bigger, so we say that the refractive index is equal to sine R over sine I.